Welcome everybody. I'm very glad you are joining today's seminar. This is the second seminar in online mode. So in response to the difficult times we have with COVID, and this will continue to have a huge impact. So we just the new cycle of seminars on digital and public humanities for the months of April until May. You can see the announcement on our webpage of the Department of the Humanities of Foscari or of our Center for Digital and Public Humanities. You will have the option to post your questions in the chat. You open the chat in the upper right corner. There's the speech bubble. If you click on that, you can post questions even during the presentation, but we then will get back to those questions after the presentation. Please try not to interrupt the presentation except for existential interventions. Please put your microphones on mute. I don't know if everybody is familiar already with Google Meet. So you can put your microphone on mute if you press Control D and reactivate it again with Control D. Or if you click on the monitor on the screen, then the button appears where you can activate and disactivate your microphone. After the presentation, we will then have a discussion of half an hour. So please post your questions in the chat, and either I will read them as a radio man, or I will ask you to activate your microphone and elaborate on your question yourself if there are no technical problems. Any other technical instructions? So this seminar is going to be recorded and published on YouTube. So please be aware of our privacy notification at the beginning of the slides. I think that's about it for now. My name is Franz Fischer. I'm the director of the Venice Center for Digital and Public Humanities, and I'm very grateful to my team. We have an excellent and active team who organizes many events, among these our seminar series, and for the seminar series especially responsible Federico Boschetti, Paolo Monella, Tiziana Mancinelli, and Lisa Spinazze. Today's speaker, I'm very glad to welcome Rodolfo Delmonte. He has been Associate Professor of Computational Linguistics at Foscari since 1987 and is now retired. He has published countless articles in international journals and conference proceedings and several books, all centered around the topics of semantics, pragmatics, symbolic linguistics, and the application of computational methods and tools. And his research themes include irony, sarcasm in political commentaries, literary narratives, and poetry. During his long career, he has been expert member of scientific committees, research council, and chair of several international conferences, teaching courses and seminars around the world. And for a longer period, he was a visiting professor at the University of Texas in Dallas. He has organized almost 30 high-profile workshops and conferences in Venice. More recently, he dedicated himself to poetry and text-to-speech technology. And it is in this context that he developed SPARSAR, a system that reads English poetry, extracting meaning, contributing emotions. And a version of that is under construction also for Italian poetry. So this is also the topic of his presentation of the seminar today. So semantics, expressivity, and synthetic speech, SPARSAR recites poetry. So thank you, Rodolfo. Welcome, and we are excited to learn more about SPARSAR.
Okay, thank you, Franz. Thank you very much for inviting me here. I hope everybody can hear me. I will try to speak up, and in case there are problems, please let me know. So poetry and speech synthesis, or text-to-speech, these two themes, they were the themes of my beginning of my career, as I did my PhD in Australia on poetry, and I started, and that was middle 70s. And at the end of the 70s, 78, 79, I started working on text-to-speech and the speech synthesis. I will not have to say much about speech synthesis. It's not, we won't have time to deepen the topic, even though I will show you a little bit about the way in which the systems, the TTS, work. And then I will do some demos using the speech synthesis systems available on the web freely. Then I will dip into the NLP and semantics in particular, just to let you know more about the way in which expressivity is produced in the system. Then I will show you the system and some analysis, and then you will have a demo of the reader. That will be the first part of the talk, and then the second part will be dedicated to Shakespeare's sonnets and the Elisabethan EME, the early modern English, which is, I think, very intriguing and very interesting too. So that's the part of the work that I'm working on, and I've been working on in the last 6-7 years. So next slide. Federico, thank you. So I will tell you next slide so that you can, once you hear that. So the the idea of having a speech synthesizer produce expressive reading and or emotions, this is all what everybody is trying to do, and everybody agrees on the fact that in order to do that, the expressive reader needs to have some ability with regard to natural language understanding. So this is something which has always been the major undertaking of most of the research in computational linguistics. But what is going on nowadays is what you have, I think you have been learning about, is the big data and the deep learning paradigm. Deep learning has got to do with machine learning, and people are trying to use this approach also with TTS, also with speech synthesis. In fact, all the systems that you can hear around on your cell phone, for instance, they are not really speaking freely. They are using, already recorded speech, and so they will not have to be using any particular natural language ability. So what we really need is a system that can produce semantics and some pragmatic features of text in order to produce expressive reading. But are there any such system, and how far are this system able to produce semantics? This is what we will look into in the talk. Okay, so let's go to next slide, please. In fact, in fact, all the systems available now on the web that you can check by yourself, and I will give you some addresses. You will have them available, and you can try them. There's a total lack of expressivity, also at the level of emotion. That's very hard to produce in any case. Few expressive synthetic speech systems, they are actually tuned to specific needs. So they would produce very special and peculiar types of expressive reading, and they will be unable to generalize, since all these systems, they don't even try to understand what's in the text. Since they're using a statistical approach, they will try to generalize what the model will tell them. But obviously, generating emotion and or expressivity requires a lot more knowledge. And some of this knowledge can be gathered from sentiment analysis. So there's some system that uses sentiment analysis, but that's all. And also there's an attempt to do that in storytelling. Nobody's trying to work on poetry. Poetry is very difficult to work on. So I'll show you now some of these TTS architecture. In particular, I will show you the IBM now, the IBM one. This will be a general architecture. What you get is a text at the beginning, which is the input to the system. And and then there's a pipeline of modules in an NLP approach, symbolic approach. There will be a pipeline of modules. On the contrary, in a statistical approach, there will be a number of statistical models, one per each task, important task, and you will see some of these in the next slide. After that, parameters are produced. They are attached to the speech units, and these speech units can vary. They can be diphones, they can be units selected by some, again, statistical approach, and they will be passed up to the speech synthesizer that will produce the speech waveform, and the output will be the spoken output. On the contrary, what you get in the current trend after the big data and the deep neural network arrival, you get an end-to-end approach. What does it mean? It means that what these people are modeling, they're modeling a text with the accompanying waveform, the spoken expression in a digital form. So they're modeling the text together with the what is needed to have the speech synthesizer directly use in order to produce speech. There's no intermediate level. Everything is being modeled at the same time. Obviously, this is very hard to do, and what happens at the end is that these models, these voices, because at the end you get a voice, and this voice is the system, and these systems, they cannot be modified. They produce only what they have been driven to produce through a model. Okay, let's go to the next one. Next slide. So this is the IBM's one, and we will listen to IBM's voice in a while. As you see, the text is passed to the DNN models. There's more than one, as you see there. The most important one will be the prosody prediction. then the acoustic feature prediction, and then eventually the waveform prediction. So that will be the one that will drive the speech synthesizer, and you will then listen to the voice. But as you will see, that's very hard. So this is an example of what Loquendo was one of an important company in Turin, an Italian important company that has been absorbed, that has been taken by Nuance, an American, much bigger company, which is the one that is now distributing voices to everybody. So every company like Amazon or other companies, they buy the voices from Nuance, and that's the pity, because the Italian company Loquendo was doing very well, and in particular, in order to, as you see there, in order to express some form of emotion or of expressive behavior, they were using speech acts category associated with a set of words or phrases or utterances, you know, short utterances that you see there on the right-hand side. There was, again, there was not a way to generalize, obviously. You know, these utterances, they had to match with the text, otherwise there wouldn't be possibly the expressive reading. Anyway, this was just a way to improve it. So lately, this has been taken from Google's attempt to introduce prosodic variations, again, for the expressivity or emotion task. And these are the conclusion of the Google's system, which is called Tacotron. So to solve the prosody problem, we need to create blah, blah, blah. But speech variability is multi-level. So everything happens at the same time. So that's very hard to do. And what they say at the end is that we also like to develop techniques to select appropriate prosody or speaking style automatically. So they are unable to do that from context, integrating some natural language understanding. But that's not working. So the website they had before is not working, and there's nothing visible. So what I will do now, I will show you what happens when we use a speech synthesizer from the web to read a poem. I've chosen this poem by Sylvia Plath. This was the last poem she wrote 1 week before she committed suicide, and it is a very powerful poem. It has got very powerful metaphors and imagery. The imagery is absolutely beautiful. And even though it is very terrible if you think that the week after she committed suicide, and the poem tells about the condition of the woman she was very concerned with. So I will now switch to the readers, and what I've marked here in this slide are the important part of the poem that need to be processed in the correct way. And basically what you see is a sequence of enjambments. Every couplet has got an enjambment, so it needs to be every couplet needs to be correctly, appropriately connected to the next one in order to be pronounced correctly. And of course, no, don't move. Stay there. Okay, stay there. Then now I will I will go to the reading, and I hope you can hear. I hope so. Anyway, the first one is the nuance, and the second one is the IBM. So I'll go with the first one.
By Sylvia Plath. The woman is perfected or dead. Body wears the smile of accomplishment. The illusion of a Greek necessity flows in the skulls of her toga. Her bare feet seem to be saying, "We have come so far. It is over." Each dead child coiled, a white serpent, one at each little pitcher of milk, now empty. She has folded them back into her body as petals of a rose close when the garden.
So, as you, I think you have been easily noticed, the system is unable to understand that the enjambments, they need to be treated differently. On the contrary, the system stops at the end of every couplet, without, obviously understanding that the last word needs to be connected to the first word of the following couplet. So, as I was saying, there's no understanding of the text, and this is done in that way. So, but that's the system that they are using. So, it's not a problem. It's not a general problem of all the system. Perhaps there's another one that works better, but the one for English, for British English, is not working appropriately. Now I'll go to the IBM one. As you will see, as you will hear, they do it differently by looking at the punctuation. So these are the two strategies. They either look at the end of the stanza, or they look at the punctuation, and the IBM one looks at punctuation.
Sylvia Plath. The woman is perfected, her dead body wears the smile of accomplishment. The illusion of a Greek necessity flows in the scrolls of her toga. Her bare feet seem to be saying, "We have come so far, it is over." Each dead child coiled, a white serpent, one at each little pitcher of milk, now empty. She has folded them back into her body as petals of a rose close when the garden stiffens, and odors bleed from the sweet, deep throats of the night flower. The moon has nothing to be sad about, staring from her hood of bone. She is used to this sort of thing. Her blacks crackle and drag.
Okay, and now I will let you hear the version by the system. This is it.
Edge by Sylvia Plath. The woman is perfected, her dead body wears the smile of accomplishment. The illusion of a Greek necessity flows in the scrolls of her toga. Her bare feet seem to be saying, "We have come so far, it is over." Each dead child coiled, a white serpent, one at each little pitcher of milk, now empty. She has folded them back into her body as petals of a rose close when the garden stiffens and odors bleed from the sweet, deep throats of the night flower. The moon has nothing to be sad about, staring from her hood of bone. She is used to this sort of thing. Her blacks crackle and drag.
Okay, so that was it. We can now continue. Federico, okay. So these are addresses where you can actually listen to the IBM one, the bluemix.net, and the nuance one. So you can copy them down, or I don't know, Federico perhaps will make it available for you. And then there's other two available. One of them makes the same mistakes as the one that we heard from the nuance. Okay, let's move on. And to next slide. So expressivity regards varying pitch and intensity, basically, as for storytelling. It requires specific prosodic patterns. But where and when does the system produce this kind of variation, and how can it produce it? So this is the problem, and this can only be done when a system for semantics is made available. Let's move to the next slide. And I'm not the only one, maintaining that the current vision, that thinks that the use of big data and deep modeling will allow understanding, natural language understanding. That's a wrong position in general. It's not only me. There's a number of other people, obviously, and I'm showing the people from the Washington University, and they maintain that there's no way of learning meaning from word forms alone. So from the surface level, there's no way of learning meaning, and so there will be no natural language understanding with that approach. Okay, let's move on to the next slide. What is the state of the art in NLP? So these are a list of modules. These modules are the ones that there has been most research going on, and results have been by everybody. They've been confirmed over 95% of accuracy. So these approaches they've been now part of state of the art in NLP, and everybody can use them. Okay, so there's a lot of systems available for doing this part of the NLP work. Let's move to the next one. Then when we move to this level would be the sequence of the previous models in a pipeline. And these two levels, as you see there, they got to do with predicate argument relations or grammatical relations in general, semantic relations. Also, this can be partly done with a good level of accuracy, but then the worst part of this would be the coreference resolution algorithm. This is very hard to get automatically. So coreference is very hard to get, and coreference is an important part of the semantics of a text, as you can imagine. So let's move to the next one. Next one, next slide. Okay. So with that level of the state of the art, there's lots of things that can be done. Logical form can be produced in order to answer appropriately to questions. There's a number of other tasks that can be performed correctly, like semantic similarity, understanding temporal expression or negation, scope of negation. And eventually, the important part, which is the one that I'm using, is the discourse structures and discourse relations. So, in other words, what happens at a propositional level, at a higher level, in order to drive the variation at intonational level. So there has been additional work done on dialogues, which, as you can imagine, require a lot more understanding of what's going on, because dialogues are usually they don't express the whole of the meaning, so a lot of the meaning must be inferred. Anyway, this work has been done, even though there's no the level of accuracy is not good enough, and so there's no availability of a system that can be shared by everybody. So let's go on. Next slide. In case you want to know what are the systems that can do semantic representation, you can go to this page, which is the shared task that has been organized by my team in Venice when we hosted this conference, Semantics for Text Analysis, for Text Processing. Okay, let's move to the next slide. And here is a list of systems that can be approached on the web. So you can just go there and see what they can do. You can also, in some cases, download the code. The code is made available in some cases. Okay, let's go on. So this is the architecture of SPARSAR, of the system that I've called SPARSAR, which has got to do with sparse, but in other words, with the fact that information information at the level of semantics is very sparse in general. So if you start from the right, from the left-hand side, from the higher part of the left-hand side, you see that at first there's a phonological and phonetic transcription, then a syntactic representation, and then a dependency representation, which is more semantically oriented. This is passed on to the level of prosodics at verse line level. Then there's a module that produces, no, wait a minute. I haven't finished. There's a module that produces poetic devices like rhyming and metrical structure of the poem. And this is passed to the propositional level and the discourse level, and eventually there's the affective pragmatic information is made to work on the waveform, on the speech synthesis to produce expressive TTS. Okay, let's look into the next one. Another way of looking at the system is by considering the three levels that interact when the final parameters are produced before producing the speech synthesis. In fact, what happens is that the first level, which is the one that produces the semantics, works a sentence level. So usually semantics and understanding is produced at sentence level. On the contrary, the poetic level, which is the second one, works at verse level, at line level. So all the important parameters are produced at line level, in particular rhyme, but not only rhyme. And then eventually these two levels, which they are not symmetrical, they need to be to coalesce, to go together when the parameters are produced in order to have a prosodically variable waveform at the end of the system, so before the speech synthesis starts. Okay, so that's very hard. That's the very hard part of it, and it's very difficult to connect the two levels. Anyway, this is what the system tries to do. Let's go to the next slide. Next slide. Just to show you, I will not go into the details. This is the parameterized text, which is the input to the speech synthesizer. So as I will say, I will not go into the details, but just to just to tell you that if you look at the first line, you see 3 parameters as the volume, which is the intensity, the rate, which is the speed, the P-bass, on the contrary, is the intonational level. Okay, and SLNC is the silence. Pauses. So these are the 4 parameters: silence, intonation, volume, which is intensity, and rate, which is speech rate. Variations of these parameters, they have been taken from research level at the level of emotion. So there has been a lot of research trying to characterize different emotions by these parameters that you see here: pitch, timing, and voice quality. So I'm taking the information from these studies. There's a number of these studies available, and I'm using that in order to characterize some of these emotions. Okay, let's move on. Next slide. This I will not go into the details of this, but just to show you just to show you the way in which these markers, the markers that you saw previously, how they are induced. What kind of information is being used. As you see there, syntactic information, semantic information, a quantifier, discourse marker, again, semantic information. A word is a subject. So again, syntactic information at the level of dependency. That's as information for word stressed emotion and other similar things. Next slide. Let's move quickly here. So this would be a list of the rules that are being used in order to insert pauses or to introduce some rule and some variation at the prosody level. Okay, move to the next one. Next slide. So this will be the previous one. Just a few words for the intonational level. Okay, the intonational control here. This is important, but again, here the important part is at the end. The sentence introduces a new topic, a change, a foreground relevant content, or a certain discourse relation. So this information comes directly from the semantics. Okay, so let's move on to the next slide. Okay, just to give you an idea of what the representation would be at the semantic level. So this will be the prepositional semantics, the intermediate predicate. They are in the middle. You see there. Okay, next slide. Go to the next slide. This will be the one that is being produced. The representation that is being produced at a certain point in order to differentiate main prepositions from secondary or coordinate ones. And there's the marker of background or foreground information, which is important. Okay, let's move on. Next slide. And here, and this will be the information attached to predicate semantic heads. As you see there, the list of these predicates, they are the nominal heads, and they are being characterized semantically in different ways. Okay, move on. All right, so We move on now to the second part, and this is dedicated to Shakespeare sonnets and to early modern English. Let's move on to the next slide. Shakespeare sonnets are they are a list of 154 sonnets. They contain, as you see, the 18,000 tokens and 3,000 types. So this, the type token ratio, which is the vocabulary richness, is fairly high, 16.87%. Okay, move to the next one. 16.87. If you see here, these are the the numbers for the major poets, major American and English poets of last year, and not only. There's also Yeats, as you see there. And there's a comparison with the Wall Street Journal, which has 1 million tokens. As you see, the variety in word forms is very low, 2.71. But if you look at the poets, they are all very high. In particular, Sylvia Plath, 21.84. You see, that is the highest. Okay. What's the poetic features of the Elisabethan sonnet? Basically, the one introduced by Shakespeare. As you see there, the rhyme scheme would be alternate rhymes, apart from the final couplet. The final couplet as a perfect rhyme, as a couple of perfect rhymes. So this applies to all the sonnets apart from 99 and 126, and also the structure, so it will be 3 quatrains plus a final couplet, excluding 145. And the meter is the iambic pentameter, but this is guaranteed by presence of contractions and in some cases marked stress syllables. I will explain more in the next slides. Go in the next slide. So just a few words about English rhymes. English rhymes, there's quite a variety of them, as you see here. And they all need to have the same stressed vowel. But apart from that, there can be quite a lot of variations. So not an easy task. Okay, go ahead. Next slide. Just a few words about the modules that takes care of phonetic and phonological translation. As you can imagine, this phonetic translation is done using dictionaries. There's a number of these dictionaries available for English. For Italian, it will be more difficult. For other languages, it will be more difficult. But for English, there's everything. The question is that the majority of these corpora, of these tools, they are not completely correct. So they need to be checked. And imagine checking 120,000 entries. That's very hard to do. Anyway, this is what has been done in order to have a completely checked dictionary, phonetic dictionary. Obviously, the dictionary doesn't contain all the forms. In particular, it certainly doesn't contain all the forms needed for the early modern English and the Elisabethan poetry. So that had to be, you know, as a number of editions completed by a companion dictionary, let's call it a companion dictionary, which has got to do with the Elisabethan word. So what is being done in this module, the system looks for syllable structures, because metrical structure is built according to syllable structure. So in order to know the meter, the system has got to divide up every word into syllables. And again, imagine the presence of a certain number of out-of-vocabulary words. This is what they're called for. In other words, words which are not included in the dictionary. So for every one of these words has got to be treated using phonological rules. Not an easy task again. So the ends, no, stay there, stay there. For rhyming analysis, the end syllables are collected. They're collected separately from all the other syllables, and then they're checked. And the scheme of the sonnet is the one that we saw, but obviously the poem that we heard at the beginning, the one by Sylvia Plath, that was not a sonnet. So the system has got to work with different types of poems, always trying to find rhyming lines. So go ahead, next slide. What are the main difficulties in dealing with Shakespeare's sonnets, and in general in dealing with Elizabethan poetry? There are at least these four, in addition to what we already said, four difficult tasks. The first task will be resolving contraction. There's a lot of this contraction, as we will see in a while. The second one has got to do with marked stress syllables or marked unstressed one. In these cases, the system has to prevent elision. So that word has got to be, it has got to be marked in a certain way in order to tell the synthesizer that that particular syllable has got to be pronounced and not elided. The third task has got to do with rhyme violations. These were typical of that period because early modern English wasn't completely fixed as far as pronunciation was concerned. And so there were a lot of these rhyming violations. In other words, words which were pronounced differently according to rhyme requirements. The fourth task has got to do with homographs, which are not homophones and belong to different categories, like the word lives or lives. And in all these cases, in order to tell the speech synthesizer which pronunciation to choose, this has got to be done accordingly. So the system has got to tell the phonetic structure of the word and the phonetic form. And eventually the fifth task, homographs, non-homophones, which belong to the same category and require a particular pronunciation of that time, an archaic pronunciation, like the word desert, which in fact is pronounced desert. It is pronounced desert because this word, it is a derivation of deserve. So the verb meaning a totally different meaning from desert, I believe. So, but this information has got to be told to the speech synthesizer. So contractions, as you see here, has a lot of these contractions, more than 900. And they have different structures. And as you see here, they need to be spotted by the system, so, and then treated accordingly. Let's go to the next slide. Next slide. Federico. Okay. So this is the way to treat contractions. Since they are necessary to respect the metrical structure, at first they require a reconstruction of the contracted word in order to be processed by the morphology and the syntax and the semantics. But then the contracted original word form must be restored in the grapheme to phoneme conversion. So when the phonetic form is being constructed, it has to be constructed on the original contracted word form. But as you can imagine, that word form is non-existent, is not a word. Is a contracted word not existing in any dictionary. So that must be created phonetically. So this is why the systems available on the web, be it from the one from IBM or the one from Nuance, they are unable to produce correct reading of a contracted word. Okay, let's go to the next slide. Preventing elision, as a number of these words, less than 40, in fact, where a syllable must be preserved from being elided. But this is difficult to do because you need to tell the speech synthesizer that syllable doesn't have to be elided. Difficult to do, as you will see. This is also something hard to produce. Okay, next slide. Next slide. And this is an example. Look at the first line. To say this title is impaneled. Impaneled, you see down at the bottom. Impaneled is pronounced impaneled, not impaneled. So the final syllable needs to be pronounced. And the same happens with, and by the verdict is determinate. Determinate needs to be pronounced. The final syllable needs to be there in order to produce the 5 iambic beats. So you see the 5 beats. So the final syllable needs to be there. Okay, go to the next one. Eventually, rhyme violation. There's over 100 violations of the rhyme scheme. As I was saying, this is due to the instability of the pronunciation in AME. So, as a number of people that have been been discussing these problems, and obviously, this is not an easy thing to do, again, because finding the violation. So the system needs to find the violation and then to decide whether to modify the pronunciation. Then the pronunciation needs to be modified accordingly. In other words, there must be a phonetic form of the word which is different from the one that the speech synthesizer would be pronouncing. Okay, go ahead. Next slide. Some examples. Sonnet 1, you see, thereby beauty's rose might never die, and then each time the hair might bear is memory, not memory. Now the word fresh ornament and thy content. Thy content, and fresh ornament, not ornament. So there will be a different vowel there. In Sonnet 10, be fairer lodge than gentle love, but it wouldn't be good because the rhyming word will be prove. So this will be love. Be fairer lodge than gentle love, and at least kind-hearted prove, and so on. So heard, beard. Go ahead. Next slide. None, no, known, stone. In order to rhyme with stone, it has to be pronounced known. Here again, die and dignity. Come, no, cum, doom. Did mercy cum, in giving gentle doom. And, no, end, find. Okay, so this is just to show you some of these cases. And so finally, I will let you listen to the pronunciation, to the reading of this one sonnet, and I'm choosing 66 because this was one of the sonnets we worked on when we organized an event at the Biblioteca Marciana. Go to the next slide. Next slide. As you see here, this was organized in 2016 for the 400th anniversary of the death of Shakespeare. And what we did was organizing an event where the two sonnets, one of them was the 66, they were put into music by a famous author of contemporary music, Claudio Ambrosini, and I and a number of colleagues, we were presenting the sonnets, I from the point of view of computational linguistics, and I also have the system read the sonnet. But now move to the next one. But first of all, we will listen to the sonnet read by Sir John Gielgud. Sir John Gielgud is the most famous Shakespearean actor, a British actor, obviously. He died not long ago. So what's the peculiarity of this sonnet? There's the word desert, which has got to be pronounced desert or dessert. Then there's jolly tie, which has got to be pronounced differently with a different final vowel. And then eventually there's a word which needs to be pronounced according to the metrical structure, disabled, not disabled. And eventually there's gone, but not gone, gone, alone, in order to rhyme with alone. So watch out, because no, stay there. Sir John Gielgud, he will produce some of these things, but for instance, he will not be able to. He will not do it. I don't know whether he knew it or not. He will not be able to produce the rhyme accordingly to the violation. So I will go down and now here it is.
Tired with all these, a restful death I cry, as to behold desert a beggar born, from needy nothing trimmed in jollity, and purest faith unhappily forsworn, and gilded honor shamefully misplaced, and maiden virtue rudely strumpeted, and right perfection wrongfully disgraced, and strength by limping sway disabled, and art made tongue-tied by authority, and folly doctor-like controlling skill, and simple truth miscalled simplicity, and captive good attending captain ill. Tired with all these, from these would I be gone, save that to die I leave my love alone.
Okay, so I'll let you listen now to the way in which the speech synthesizer on the Mac, but it will be the same with the other ones, would read the text raw as it is. So if you move to the next slide, move to the next slide. So you see that there's the Alex, that's the voice. So it will be an American voice because that's the only one that can be used. But in fact, I can also use Daniel, but I'll have to change the voice in the. So I will leave the Alex one just to let you hear that none of the contractions can be produced, and none of the of the violations can be respected. So here it is.
Sonnet 66 by William Shakespeare. Turdy with all these, for restful death I cry, as to behold desert a beggar born, and needy nothing trimmed in jollity, and purest faith unhappily forsworn, and gilded honor shamefully misblacked ye, and maiden virtue rudely strumpeted, and right perfection wrongfully discracked ye, and strength by limping sway disabled, and art made tongue-tied by authority, and folly, doctor-like, controlling skill, and simple truth miscalled ye simplicity, and captive good attending captain ill. Turdy with all these, from these would I be gone, save that to die, I leave my love alone.
So as you notice, there's no way for the system to identify the contractions. And sorry, but here there's a number of these they have been completed, and I didn't realize. Anyway, we can now listen to the way in which the system will produce it, and that will be the end of my presentation. So.
Sonnet 66 by William Shakespeare. Tired with all these, for restful death I cry, as to behold desired a beggar born, and needy nothing trimmed in gilded tie, and purest faith unhappily forsworn, and gilded honor shamefully misplaced, and maiden virtue rudely strumpeted, and right perfection wrongfully disgraced, and strength by limping sway disabled led, and art made tongue-tied by authority, and folly, doctor-like, controlling skill, and simple truth miscalled simplicity, and captive good attending captain ill. Tired with all these, from these would I be gone, save thou to die, I leave thy love alone.
Okay, so that's it. I'm ready to answer two questions.
Thank you very much, Rodolfo Delmonte, for this highly impressive insight into the complexity of computational linguistics.
Yes.
And this impressive result. So I see here great potential also for business and other fields to benefit from these results and this software. So, but first, I would like to invite everyone to post your questions into the chat, so that you have the chat bubble in the upper right corner. Post your question, or just write your name if your question is too complex, but it's very welcome to have clear and short questions. And then you can either put your microphone, activate your microphone, or I will read it to the audience. So I open the chat myself.
Okay. Thank you. It was a pleasure.
Yeah.
I said thank you. I said a pleasure.
So in case you have to prepare, so you can also, you are also invited, because there was a lot of technical linguistic jargon. So this is an interdisciplinary seminar, so please don't be afraid to ask also simple question also for understanding. So this was high-level linguistics, and not all the technical terms are familiar to everyone. So these questions are absolutely right, and I'm sure others will be happy if these terms can be clarified in a first step.
Yeah. I mean, of course, there's more than one seminar in the presentation. There will be at least 5 seminars, you know, one for each topic. One will be for the topic Shakespearean sonnets. Then one will be for the topic speech synthesis. One will be for the semantics. One for, you know, I'm quite aware of the fact, you know, that I haven't been able to say much of any of these topics because the time was, you know,
Sure.
But if you have any questions, specific questions, then I will try to answer.
I'm glad you were able to provide this large overview, because so I'm myself, if I start, I'm a textual scholar, and of course I am dealing with all these competing structures and levels of textuality. And I do this by hand, usually as an encoder, and so this is getting easily very messy and difficult to keep clear the various levels. But I mean, it is possible. So I wonder. It's not magic what you presented. I think it's clear. So it's really structured information, annotation on the original material, and I wonder if there are ways to make this visible or export into formats that then can be of use for other scholars who are not working with linguistic annotation.
Oh, sure. The system produces quite a lot of representations. You can produce, you know, all the representation at the phonetic level and everything at the semantic level. Thank you, Massimo. Ciao. And so everything is recorded on a file. So there's lots of files that the system produces, at least 10 files. Of course, they can be used. They can be used for further processing. Some of them are they are in XML format, so they are already in a format that can be seen on the web, can be directly put on the web. Others, they are different. They're simple text, but I mean, there's a lot of information that can be used, and some of them I haven't been able.
Unfortunately, you are frozen on my computer. I hope. Now you're back. You're back. We lost 30 seconds or something. You were.
Yes. Okay. If you have a question, please go ahead.
Paolo has a question.
Yeah,
Okay.
may I? Hi, I have 2 questions. Quick one, did I understand correctly that you are combining sentiment analysis with the so to speak, meaning analysis? So linguistic analysis with sentiment analysis. That's the first question. And the second question would be enjambment. This is more of a humanistic general question. There are 2 approaches towards reading enjambment, towards reading poetry. One privileges the metrics, so you want to make some sort of stop at the end of the line, and the other one, which is more contemporary, which is ignoring the line structure at all when you do enjambment. Umberto Eco, for instance, used to say, hey, you had to read poetry respecting the lines somehow. Metrics. Okay, thank you.
Yeah, you're right. So the question about, I'll answer to the second one first. The question about enjambments is that the intonational culture doesn't have to be interrupted. That's the difficulty. On the contrary, if you listen to the reading by IBM or the other one, which I didn't produce now, but I mean, they're both, since they don't know what's going on at the end, they interrupt the intonational contour. So the intonational contour goes down as if the meaning would be coinciding with the line end, but the meaning doesn't coincide with the line end. It continues. So you can introduce you can also introduce a small pause this is what I do. I introduce a small pause, but then I keep the intonational contour at the same level, both at the end, at the line end, and at the beginning of the following stanza. In that case, they are at the stanza level, but they could also be not at the stanza level. The enjambments, they could be inside the stanza, and there would be the same problem because they would stop there in case they have that information in their program, so they will be inside the program. And as to the first one, yeah, the sentiment analysis will be one of the the affective analysis will be one of the components, which is done together with the semantics. The semantic analysis will be a propositional level. On the contrary, the sentiment analysis will be done at word level, even though the final decision on whether a certain proposition is to be computed negative or positive, the decision will be done at propositional level. So the two things would go together eventually in order to tell whether a proposition is negative or not. In case there are two negation, usually this is what happens. In case there are two negation, then the proposition would be computed positive, not negative, and the intonation would be kept accordingly. Usually what happens is that in case there's a negativity at propositional level, the intonation will go down. And this, I think you heard some of these cases. Well, I mean, it's difficult to tell, but this is what happens. The intonation will go down rather than up. And as I was saying, I also have this imagery level, psychological imagery level representation of the text that I'm not using, however, yet. So I have a number of other things that I'm not yet using because it is difficult to put them into the same level, into the same final computation. So I'm still uncertain whether to use something more or something less. Anyway, I hope I replied to your questions.
Yes, thank you very much.
Are there any other questions? Otherwise, so I'm a bit hesitant to ask this question because it's everywhere. It's not COVID. It's about artificial intelligence, and so we have so much progress in the developments of the application of artificial intelligence, and I see such an enormous amount of expert work here in the back to make this happen. So to make the synthesizer speak in a way that one would not hope or imagine in the past, that software be able to really read poetry in a meaningful way. Do you know of projects or where you can compare results, or do people? I'm sure people do apply artificial intelligence to achieve similar results. And yeah, what do you think from a different approach to just let the computer do? And yeah.
What the current approach is from artificial intelligence, what they have achieved is an improvement on the quality of voice. So the quality of the speech synthesis is terribly improved, and that improvement is really important because you hear a synthetic voice which sounds very much like a human voice. But by doing that, the question is that by doing that, they in fact what they have done, they have introduced such obstacles to the possibility to highlight portions of the text, portion of a word, in order to focus on them and have them pronounced differently. So they can only do that, as I was saying, in case there's some there's music. That was nice. So as I was saying, it's difficult to operate at word level and to introduce variability, prosodic variability. That's almost impossible, because what they do at the prosodic level, they would have to follow a model again. So they will use this model in order to generalize on the intonational level and the other 3-4 levels needed. So eventually, what comes out is almost a totally flat, impersonal reading without any expressivity. This is what everybody says, and I don't think they will be able to improve on that. That's a pity, because the voice quality is very important, and it has improved a lot. Anyway, the pioneering people in this field, I'm referring to Alan Black in particular. What they maintain is that people have got to combine what is called articulatory synthesis together with the latest improvements, which is a very hard thing to do. So I think that they will try to do that, but it will take quite a lot of time. And the problem is, what is the actual problem in that is that people they've been using the same tools that have been using and have been successful, very successful, in speech recognition. Speech recognition has improved quite a lot, and the machines now they can recognize speech quite easily. So they've been using that same technique with speech synthesis, but speech recognition works with a very limited number of units. That is, the phonetic units that are being addressed, just a few, say 4,000, 5,000. On the contrary, speech synthesis has, unlimited vocabulary. All the words of any language, needs to be addressed. That's not comparable. I mean, that two totally different problems. They're being compacted in one single problem, which is the wrong thing to do, which has been the wrong thing to do. So, dealing with the phonetic units in one case, dealing with unlimited vocabularies, which is the other case, producing speech synthesis. Producing speech synthesis needs to have a different approach, more difficult, obviously, a lot more difficult. Okay, there was another
question from
asking questions.
Tiziana Mancinelli. Sorry, don't want to interrupt. Tiziana, you have a question?
Yeah. No, it's actually he actually answered my question. So, but I have another one. I'm just wondering whether you apply those methods in texts with multilingual. Texts with different languages like English, such as English, French, or Latin. Which is very common sometimes to find. But I guess he's frozen again.
Rodolfo, we can't hear you. Did you get the question? In the meantime, we had a short visit of chat or online seminar trolls, but it was a little bit childish, but we don't care too much about this. Important we get Rodolfo back. into the conference. Your microphone is on mute, I think.
He actually left, so yeah.
Hope we can get him back. Has someone, Federico, do you have different way to, there he is. Rodolfo, I'm glad you are back, but your microphone is on mute.
Okay, here it is.
There you are back.
All right.
Okay, did you get the question from Tiziana Mancinelli, or otherwise she can repeat?
No, I didn't hear it. I'm sorry.
Okay, no problem.
I was just wondering whether you applied those methods on text with different languages. That can be with words in French or Latin or
yeah. That's also one of the reasons why the statistical approach has been taken. It has been taken by the majority of people because it allows easily to switch from one language to the other. And in case you want to do the same thing with a deep linguistic processing approach, then it will take quite a number of years and a big team of linguists working with you. You know, I think IBM could do that, but they don't want to do it. So it's not commercially viable. On the contrary, the statistical approach allows you to to work on different languages much easily. So what I'm doing now is trying to produce the same number of resources needed for Italian, even though this will require a lot of work. But now I'm retired, so I don't have much work to do, so I can actually dedicate myself to what I like most. So Italian will be the next language. But of course, I could be working on German and French next. But again, that will require trying to recover all the resources needed, all the vocabularies, all the dictionaries, phonetically, phonologically, semantically, and so on and so forth, and then have all the modules connected together in order to have a speech synthesizer. Speak in other languages, but it will take a lot of time, obviously.
Further questions? I think we have still 2 or 5 minutes for more questions. I check. Daniele, do you want me to read it, or do you want to read your question, or is this a comment for the? So we will copy the chat and make it available. So if you're interested in comments, not a question actually.
Sure.
Is this question, Daniele? It is. Okay, I read Daniele's question. It would be interesting to know about speech rate at the colon level. You take into account it at lower levels, i.e. syllable or word. What about cola? What is those parts of the verse defined by caesura? Do you have any data about it? It would be nice to see how the speech rate goes with colon length, as in some poetic traditions like recitative Greek, the longer the colon, the higher the speech rate, and vice versa.
The speech rate, well, the speech rate depends on the value of the parameters. It can be modified, obviously, if I modify the parameters. Sorry, perhaps I didn't catch all the question.
I agree. very complex question. So it's very, very specific references to Greek and ancient languages. So maybe that is too far at this point. But we have another question from another philologist, Federico. So please go ahead.
Yeah, I have a general question. I think, and I guess that also Rodolfo think that poetical language is obviously more difficult than the typical language that is analyzed by NLP. So if you solve some issues in the poetical language, in the literary language, that is very complex, you can solve something also in the other fields. Okay, so the question is why they don't invest in these tasks, in these very complex tasks. I mean that if you are able to pronounce, okay, you are able to have the text-to-speech of Shakespeare, okay, then it's simpler to read newspapers and so on. Okay, so why they aren't interested in investing in these tasks?
Well, they're not interested for the reason that I was telling you before, that that you need to have you would need to have the same results in many languages at the same time, which is something very hard to get, first of all. And then, well, if you were referring to Italy, why in Italy we don't have funding dedicated to this I think interesting enterprise. I don't know why. We have been trying to get a proposal approved at the national level, but they rejected it. In fact, actually they accepted it, but that they didn't finance it. So I don't know. I mean, it's poetry is. I don't think it's at the heart of the people or the decision-making people. They're not very much interested in that. Of course, I mean, having a system that can read poetry, it can read much better stories, short stories for kids, or newspaper. Obviously, it can read newspaper quite much better than any other reader. But as I was saying, I've been trying to get in touch with these people, the ones that produce ebooks, read audiobooks, sorry, not ebooks, audiobooks. But they're not interested. What they would do, they would ask human beings to read things. They will not be using machines to read. Even though having a machine read, it could be reading anything, anything just being printed, just coming out, as long as it is being made available in a digital form. But everything now is being made available in a digital form. So that wouldn't be the problem. I don't know. This is it. You need to produce your own company, and I'm sorry, but I'm not the one who cares about producing a company. Even though I've been trying to do that, but then it was the wrong choice. So anyway.
Well, I myself spontaneously see a lot of potential and projects where to apply. So our one characteristic of our center is that we have this interdisciplinary field, which is also in the field of arts and public arts. So I don't know. I have thousands of ideas. So to produce automatically poetry and make it immediately read. So you could have an installation that reads endlessly into the future good poetry, and with a synthesizer that reads it actually also in a stimulating or in a semantically correct way, or correcter way than other machines do. So I think in this direction there's a lot of fields to apply this speech, the synthesizer software, and the other part is inclusion. So when we create digital editions, for example, we always have to think also to remove barriers, and to make text read is one easy thing to do if you are able to implement it into a scholarly edition, for example. And if you're dealing with poetry, then I mean your software would be the first choice. So if you're dealing with English poetry, of course, but in general, I don't know. There are many other colleagues, projects, activities to connect to, from research to public art or wherever. So,
yes,
what
good.
do you think about this?
I'm ready for that. Okay.
Very good.
I'm willing to participate.
Yeah, let's do something. So we have
Sure.
Carolina still here. Carolina, I'm sure she has fantastic ideas to make to turn this into an art project. But I mean, the possibilities are fantastic. So I'm really impressed by the level of quality of the reading. So that's my opinion. Yeah.
Yeah.
So, any other ideas in this direction, or further questions, comments? Otherwise, we are already beyond 1 hour and a half. Carolina says we will figure out something. So
Yes.
when she's in, safe. Then
we can have a chat. We can have a chat together, and before we will be allowed to meet in person.
Yeah.
We can have another meeting, another virtual meeting before that, if you want. I mean, I'm ready to participate. Yeah.
Wonderful.
Good.
So if there are no further questions, comments, so we will publish this seminar, so the video, we will publish also the chat, we will publish your slides with all the references to the software you presented, so people can check and experiment with the material. The next, and we are in the course of collecting all that information on our website, so it's not easy to write also YouTube here, GitHub there. So what we will create a point of reference for all the materials, so everyone can find what he or she is looking for.
Sorry, Franz. I have just an addendum. There's a website where the system can be used directly on the web. So this website, I will give the reference to Federico, so that he will make it available together with the other materials. So if people are interested in
yeah, absolutely. Please do share all the materials and references you have.
Okay, I will give that reference.
Okay. Can start from there.
Okay, thank you.
So everybody is invited to attend our next meeting. Next week we have Sarah Tonelli, and she's presenting. So this is a catch up from the cancelled seminar in March, and she will talk about her latest research on cyberbullying and Islamophobia, and about building tools and data sets to detect online hate speech. So very so even a little bit close to your field of research, Rodolfo. And the week after, it's Mary Redmond, and she will talk, so our visiting professor, about creating interactive narratives in cultural contexts. So I think this all fits nicely together. And yeah, everyone is invited. We will send not annotations, avisi, through all the channels that we have at our disposal. And please visit our website. Everyone can join our center as a member or as an affiliated person via our website. Then you are sure to receive all information when there are news.
Okay.
Thank you 1,000 times, Rodolfo, for this highly interesting overview and this introduction into a very rich field with a lot of potential. So thank you very much.
Yeah.
In the last seminar I attended, people were invited to activate the microphones at the end and clap. So everyone who wants to join me to thank you.
Okay, thank you.
This is your applause. Your virtual
Okay.
applause. Okay. Thank you very much and
Bye-bye.
goodbye. We
Ciao. Ciao,
Bye-bye.
everybody. Bye-bye.